Welcome back to the deep dive. So, our mission for today is a bit different. We're going to take a stack of really specific technical notes and see if we can pull a universal insight out of them.
We're diving into the world of command line applications, or CLIs.
Yeah, exactly. Those little scripts you use every day to, I don't know, automate backups or manage files.
Right, and they start simple, but as our source notes show, they grow. They end up needing really robust foundations.
And our source for this deep dive is a set of decision notes from a seasoned software developer. He calls himself an old software plumber, which I love.
And he's making a huge shift, moving his whole workflow from Python over to Haskell.
So his very first roadblock is, how do I handle command line arguments? Which library do I pick?
And what makes it so interesting isn't just the tech choice, it's the philosophy behind it. This developer follows a really strict rule.
The standard library first approach.
Yes, and we should probably unpack that a little.
Okay, so what does standard library first actually mean to him? It sounds simple, but it has these huge architectural consequences, doesn't it?
It does. It means he's prioritizing stability,
Yeah.
long-term maintenance, minimizing dependencies above almost anything else.
Even above like cool new features or cleaner code.
Oh, absolutely. Even above syntactic elegance or writing less code. He wants the batteries included solution, the tool that's still going to be supported by the core language developers 10 years from now.
So he's willing to write maybe an extra 100 lines of code today if it saves him from a 3-day dependency nightmare years from now. That's a serious trade-off.
It's a huge trade-off. And for you listening, that's the core tension we're going to explore. Does this desire for built-in stability in Haskell hold up against the benefits of more modern external tools? We're going to look at the two main options. Okay, let's unpack this.
So let's start on familiar ground. Since he's coming from Python, his notes begin there. He's kind of setting his baseline.
Exactly. And in Python, for building CLIs, he always uses the built-in module, optparse.
Which is such a telling choice.
It is, because the Python world has moved so far beyond optparse in terms of, the developer experience. The notes even admit there are all these powerful modern alternatives out there.
Right, he mentions a few. Click, typer, fire. So my question is, if you're moving to a language like Haskell, which is known for its elegance, why would you actively choose the older, more wordy tool in the language you're leaving?
Well, that all comes down to that architectural style and the risk assessment we talked about. Argparse is what you'd call imperative.
Okay.
You define everything step by step. I want an argument called X.
Yeah.
It needs to be an integer. If it's missing, show this error. It's all very explicit, very manual.
And the other options, the notes say they're all about cutting down on that manual work with, what does he call it, syntactic sugar.
That's it. So click uses Python decorators.
Mm.
You just put this little symbol above a function, and boom, it's a command line utility.
And typer takes that even further, right? It uses type hints.
Yeah, so you just say a variable should be an int or a string, and the library figures out the rest. It basically gives you parsing and documentation for free just by using modern language features.
And fire is even more abstract, using something called introspection.
Which is where the library literally peeks inside your code, your function, or your class, and just automatically figures out what inputs it needs. The code becomes its own documentation.
So compared to the painstaking setup in argparse, it's almost zero effort.
Almost zero. So when you see him deliberately choosing the explicit, verbose, built-in argparse, it has to be about stability.
It's all about avoiding dependency risk.
It is. The notes are clear. When you bring in external packages, you introduce risk. It's not just about a package maybe being abandoned one day.
It's about supply chain complexity, breaking changes and updates.
The whole mess. You have to constantly manage those tools. But argparse, it's part of the Python standard library. It's as safe as it gets.
It's the safe haven. If Python is installed, argparse just works. So, now he gets to Haskell. A clean slate. Does that same philosophy, stability over elegance, still make sense?
Well, he certainly tried to apply it. His first move was to look inside Haskell's core libraries, the base package for that batteries included tool.
And what did you find?
He found system.console.gap. This is our first contender. And, his pedigree is impeccable.
But it's the direct equivalent of argparse.
Even more than that, it's modeled directly after the old venerable GNU GetOpt library, the standard Unix way of doing things that's been around for decades.
Okay, for a developer who's obsessed with stability, that sounds like a dream come true. It's old school, it's rock solid.
It is, and he looked around the ecosystem and saw it's used everywhere. We're talking about huge foundational Haskell tools.
Like what?
Like Cabal, the main build tool, and Pandoc, the universal document converter.
Yeah.
They both rely on system.console GetOpt, or at least forks of it.
So it's battle-tested, it's mature, it fits his philosophy perfectly.
It's a perfect match.
But this is where it gets really interesting. If it's so stable and so foundational, why on earth would he even consider an external library? What's the catch?
The catch is the hidden cost of that simplicity. The notes describe its features as, and I quote, quite elementary.
Uh-oh.
While it's great at parsing the arguments, the simple, absolutely essential task of generating a help menu, the thing you get with help,
Yeah.
it requires significant manual effort.
Ah, the classic developer pain point, boilerplate. So you're saying he has to write a bunch of extra code just to handle line wrapping and aligning columns for the help text.
Exactly. You define your options over here, and then you have to manually write a whole other block of code just to document those same options over there.
That sounds like a massive waste of time.
It is, especially for an old software plumber who's all about efficiency. He might gain stability, but he's losing hours to these really menial documentation tasks.
So he's stuck. His philosophy points him to this simple, stable tool, but its very simplicity creates a huge productivity problem.
And that forced him to ask the question, is the dependency risk of an external library actually worth the automation it provides?
Which leads him to the modern alternative.
Straight to it. In the Haskell world, that path leads directly to optparse-applicative.
And this is where we need to talk about their architectural style, because this isn't just a tool with a few more features, it's a totally different way of thinking, isn't it?
A fundamentally different way, yes.
Yeah.
So when he evaluated optparse-applicative, he ran the same checks. Is it stable? Is it maintained? Is it widely used?
And the answer.
It passed with flying colors. It's used by Stack, which is, probably the most important Haskell build tool today. A massive vote of confidence.
But let's get into the why. What makes it so much better than the simple GetOpt?
It's the shift from imperative programming to declarative and applicative programming. Remember, with GetOpt, you define the flags first, one by one.
Step 1, define flag X. Step 2, define flag Y.
Yeah, right. Optparse-applicative completely flips that around. Instead of defining the command line options themselves, you define the final data structure you want to get out at the end.
The Haskell data type.
Exactly. You define the shape of your final result first.
So if I want my app to produce a config object that has a file path and a log level, I define that config structure first.
Precisely. And then, using Haskell's really powerful type system and these things called applicative functors, the library basically works backward from your data type.
Okay, wait. So because the library knows the complete structure of what you want,
it can infer everything else automatically. The help text, the documentation, which fields are mandatory, all the formatting. It's all generated for you.
That's the breakthrough. The library does the boilerplate for you. It knows you need a flag for a file path because your config type needs a file path. GetOpt just knew you defined a flag, but it had no idea what its purpose was.
It's the difference between telling a bricklayer where to put every single brick versus just handing an architect the final blueprint and saying, build this.
And the result is type safe. It's impossible to forget the documentation.
And it completely eliminates that significant manual effort he was worried about.
And the notes mention he even used a modern tool for this classic debate. He tasked an AI to generate a detailed comparison table.
Which is a great point about modern engineering, right? Even when you value old-school stability, you can still use cutting-edge tools to analyze your trade-offs. He didn't just rely on gut feeling. He got a synthesized, side-by-side evaluation.
So after the philosophy, the boilerplate, the deep dive into applicative parsing, and the AI comparison, what was the final call for the old software plumber?
The conclusion was a reluctant but very clear victory for the modern approach.
He went with optparse-applicative.
He did. The notes say that while his first instinct was the purity of the built-in system.console GetOpt, the analysis just confirmed that optparse-applicative is the more modern, robust, and accepted choice for Haskell development.
It gave him the automation he needed without really sacrificing the stability he demanded. So the standard library first philosophy, it kind of failed its first big test in Haskell. The hidden cost of simplicity was just too high.
It was definitely tested, but I wouldn't say it completely failed. And that actually leads us to the most valuable takeaway from all of this.
So what does this all mean? He chose optparse-applicative, but the notes suggest he didn't just throw the other one away.
Correct. His final action was incredibly pragmatic. He decided to start using optparse-applicative right away for his current project.
Okay.
But he kept system.console, GetOpt, in his back pocket, specifically saving it for a future project. This goes way beyond just picking a winner.
That is fascinating. So it's not just hedging his bets, he's making a conscious choice to maximize his own knowledge.
And this raises a question that goes way beyond just Haskell programming. The developer's final thought in the notes really sums up a universal principle, he says, but why limit yourself to a single choice? Embracing both to maximize your perspective and exploring every possibility.
It's a shift in mindset, isn't it? The goal isn't to find the one best tool, it's to understand the entire spectrum of solutions.
By using both, even just one after the other, he now deeply understands the fundamental trade-off. He knows the minimal dependency risk of GetOpt versus the massive time-saving power of optparse-applicative.
You gain perspective by looking at both sides of the coin.
You really do. He now has a low-dependency option ready for tiny scripts and a full-featured modern option for everything else. He's mastered the whole landscape, not just a single path through it.
And that leaves you, the listener, with a final thought to mull over. What's the real cost of chasing simplicity if that simplicity, like with GetOpt, ends up creating a ton of manual effort down the line?
And where in your own work or your own learning could you benefit not from picking a single winner,
But by actively embracing competing tools, the built-in one and the modern one, to really understand the trade-offs in your own ecosystem.
the learning really happens in that comparison, not just in picking one and moving on.
Precisely. That's all the time we have for this deep dive. We hope this gives you a bit of a shortcut to understanding the complex compromises developers are always making, whether you're writing Haskell or just curious about what drives these big architectural decisions.
Until next time.